Quantum dots are semiconductor particles a few nanometers in size. They have optical and electronics properties that differ from larger particles due to quantum mechanics. When illuminated by UV light, it fluoresces and produces different colors of light. It is currently a central topic in chemistry, specifically material science and physical chemistry. Because of the fluorescence properties of quantum dots, the materials is used in many areas, like in biological analysis and in displays. However, current ways of synthesizing quantum dots utilizes heavy metal, which is not environmental friendly and also very unhealthy. Recently, researchers have also shown that quantum dots can be synthesized from carbon. So I decided to give this method a try by using a common carbon source, sugar. In order to use the common table sugar to synthesize quantum dots, we first need to turn it into simple sugars. The table sugar we use every day is sucrose, which is a type of complex sugar and will be hard to break down into carbon quantum dots. The sucrose must be broken down in a process called inversion into two types of simple sugar, fructose and glucose. We perform inversion by putting the sugar into an acidic environment and applying heat. Here, I am dissolving the sugar into vinegar to do that. Next, I put the sugar and vinegar solution into the microwave to apply heat. This completes the inversion process. Now that we finishes microwaving the sugar and vinegar, we're left with monosaccharides, or simple sugar, in an acidic solution. The simple sugar molecules can act as the carbon source, and they will synthesize and form into quantum dots by themselves. However, this process requires to be done in a basic environment, with heat, so we need to neutralize the acid first. I performed this using the most common item, baking soda, and I slowly added the baking soda into the solution. This process produces a lot of carbon dioxide bubbles, as we can see from the equation, so we must add the baking soda slowly, or else this will turn into a messy first-grade volcano experiment. I added the baking soda until no more bubbles form in the solution, and then I microwaved the solution again to speed up the quantum dots formation. As you can see, I microwaved the solution for a long time, checking in between to make sure that it doesn't burn. You can also see the color of the solution getting darker because of the increase in the concentration of carbon quantum dots forming. Now, the carbon quantum dots are finally complete. Let's test it. I closed the lights in the room and shone a beam of UV light on the quantum dots solution. I don't see any fluorescence. That is because the concentration of the quantum dots is too high. Now let's try dropping the concentrated solution into tap water to dilute it. There, beautiful green fluorescence. The method is a success. We can see that the carbon quantum dots we made exhibit a green fluorescence under the excitation of UV light.